7.3 Power functions and function operations. A big part of 7.3 is one of those things that we all know and love, domain. No, domain, in case you've forgotten, all possible x values or inputs, all possible input values. So domain is going to be a big part. We can't forget about that. Let's get into power functions and function operations. We're going to come up with two different functions. The first one is f of x. F of x is going to be 3x plus 7. I'm going to have g of x. G of x is going to be 2x minus 8. Now, for these examples here, and there's going to be a bunch of examples, what I want you to do is find the following and state, oh, that's a weird state. State the domain. And state the domain. Given this f of x and given this g of x. So, number one. Let's figure out what number one is going to be. Number one is going to be f of x plus, and then we got g of x. Number two is f of x minus g of x. Number three is going to be f of x. Any guesses? That's right. Times g of x. And the last one, I bet I don't even got to say it. You already wrote it down. F of x divided by g of x. Okay, so I'm going to ask you to do these 4 examples right here. Now, before we even get started, I want to start with something else. Let's talk about the domain of f of x. What is the domain of f of x just the way it is right here? Well, like we talked about in chapter 9, what values am I allowed to stick in for values of x? Well, this is America. I can put in whatever I want for x, right? There's not a denominator there that's stopping me, and there's not something else there. And we'll talk more about that later. But for right now, so the domain here is going to be all real numbers. Well, what about g of x? What's going to be my domain of g of x? Again, this is America. I can do what I want. I can put in anything I want. All right, so let's get back to this, to these problems here. F of x plus g of x, well, that's going to be 3x plus 7 plus 2x minus 8 for a grand total of 5x minus 1. That's our answer there. Now, what's the domain of 5x minus 1? Well, the domain is indeed all real numbers. I should probably pick a different color for that, huh? Let's go with orange. All right, then number 2. Similar thing. The thing is, though, 3x plus 7. Now, because we're subtracting, we got to be careful here. Minus, we're subtracting the quantity of g of x. We got to put parentheses around 2x minus 8. Now, we could have put them here too, but because it's adding, it's not a big deal. But that minus, you know how that minus gets us. We got to watch out for that, because if we add the opposite, what we should get here is x plus 15. X plus 15. So, what's the domain of x plus 15? Again, it's all reals. F of x times g of x. 3x plus 7 times 2x plus 8. We have to FOIL that out, and we should get, long story short, I forgot my purple. We should get 6x squared minus 10x minus 56. That's just f of x times g of x FOILed out. And the domain of that, now that x squared is not changing it, not changing stuff. I can still put in whatever I want. Domain here is all reals once more. But this fourth one, that's where it starts to get a little tricky. Not that tricky. It's still the same. It's still 3x plus 7. Oops, I got the wrong color again, don't I? 3x plus 7 over 2x plus 8. And I can't simplify anything, right? The addition messes it up where I can't just cancel out the x's or anything like that. So that's our final answer there. 3x plus 7 divided by 2x plus 8. But the domain, this time the domain is a little bit different. It's got a denominator. And since there is a denominator, the denominator cannot be 0. So what values of x would make the denominator 0 here? Well, you could set the denominators equal to 0. 2x plus 8 equals 0. Long story short, you should get x equals -4. So our domain is all real numbers except x cannot be -4. All right? If it makes the denominator 0, we can't do it. So that's a little bit of function operations. We were given two functions. We did the operations, the mathematical operations on them. We add, subtract, multiply, and divide. And then we just take our answer and we figure out the domain. But remember, I also did the domain at the beginning of the problem with f of x and g of x. Let me show you why. Let's do a new f of x and g of x. F of x in this next example. Oh, f's going to be blue this time. F of x is equal to 4 times x to the 1/3 power. And g of x is going to be x to the 1/2 power. All right, now, for some people, fractional exponents can work fine with. Those kind of creep me out. So here's the thing. Before I go any further, first thing that I'm going to do is I'm going to rewrite this as 4 times the cube root of x, right? Because the denominator is the index. And then g of x here is going to be, that's right, it's the square root of x. Now we're still going to try and figure out what's, I'm going to start with a new number 1. Now we're going to do f of x times g of x here. And we're also going to do f of x divided by g of x. But before I get started, let's talk about the domain of this first function, of f of x. What's the domain of f of x? Well, this is a cube root. I can take the cube root of positive numbers, right? For example, the cube root of 8 is 2. The cube root of 125 is 5. Positive numbers I can take the cube root of. 0 I can take the cube root of. What about negatives? Can I take the cube root of -8? Sure. The cube root of -8 is -2. The cube root of -125 is -5. So I can do anything. It's America. I can do whatever I want there. I can put in any value for x, positive, negative, 0, and all's good. But in G, it's a little different. The square root of 4, of course, is 2. The square root of 81 is 9. What's the square root of 0? It's 0. But can I take the square root of negative numbers and get a real solution, a real number? No. We know that we get i's. So here, the domain here is all real numbers. However, x has got to be greater than or equal to 0. All right, so the domain here is greater than or equal to 0, or all real numbers, but x has to be all real numbers greater than or equal to 0. We just write it like that. Okay, now that's going to be important for what we're doing here. Let's talk about f of x times g of x. F of x is, now here's the thing. I wrote it both ways, and sometimes you got to decide. Sometimes it's easier to use a fractional exponent. Sometimes it's easier to use the radical form. Now in this case, since I'm multiplying, think of this. cube root times square root. Since they're different roots, I can't go and combine them. So I'm going to use the exponent form so I can use the exponent rules. So here I got 4x to the 1/3 times x to the 1/2. And now that I have the same base, I can add the exponents together, and we're going to get 4 times x to the 5/6. Now, while we use the fractional exponents to get this answer, our final answer should be written as in radical form. So this is 4 times the 6th root of x to the 5th power. Okay, now that's our answer here, but we got to talk about the domain and range again. Let's talk about when it was here, when it was an odd index, when the index was odd. Our answer was all real numbers, because remember back from 7.1, if we have an odd index, there's always going to be one real root. Remember that? If it's odd index, maybe I should say index, there's always going to be one real root. However, if it's an even index, that's when we had 3 different scenarios. Positive gave us 2 reals, 0 gave us 1 real, and negative gave us no reals, because you cannot take the square root of a negative number. That's what happened with g of x. Well, this is an even root. Much like square root, 6th root is like square root, so it's got an even index. So I can't have any negative numbers inside of here. And since this is raised to the 5th power, even a negative number raised to the 5th power is still going to be negative, and I can't take the square root of a negative number, so our domain here is x is greater than or equal to 0. All right, so the domain, because of the even index, it's got to be greater than or equal 0. Let's talk about the next one. The next one, we got 4x to the 1/3 over g of x is x to the 1/2. Now, using the exponent rules, we would do 4 times x to the 1/3. We would subtract these exponents. So we're going to get 4 to the negative, oh my goodness, 4x to the negative 1/6 power. Let me make that purple. Uh-oh, I'm running out of time here. So this is 4 over the 6th root of x. But I got a radical downstairs, so I got to fix that. We're going to multiply top and bottom by the 6th root of x to the 5th. And we're going to get 4 times the 6th root of x to the 5th over x. So that's our final answer here. 4 times the 6th root of x to the 5th divided by x. So what's the domain here? Well, much like in number 1, we got 4 6th root of x to the 5th. It's an even index, so we can't have negative numbers. We can take the 6th root of 0, but we can't have negatives. But now we have a denominator as well. So that means that our domain is, it can't be negative and it can't be 0. So that means that x is going to be greater than 0. We're not going to include it this time because the denominator makes it 0. So here's the 2 big things that we need to be down with today. It's going to affect our domain. The domain, because this is America, domain is usually all real numbers. Unless, and there's 2 scenarios. 1, what makes the denominator 0? And 2, if we have an even index on a radical, even index on a radical, we have to consider that. Tomorrow in class, we're going to talk about composite functions.